Jai Hind. There is a differentiation question. Find differentiation of y equal to square root x minus 1 upon square root x whole square. We can do this question by opening the whole square method or by using the chain rule method. So according to chain rule, we write dy by dx. It means differentiation of this. So differentiation of this, it means we use chain rule here. So according to chain rule, if there is x square, this is 2, it means square, and this suppose whole is termed as x, then we use this identity of differentiation dx power n upon dx, it is equal to n x power n minus 1. According to this, we write as 2 square root x minus 1 upon square root x. Since there is not x, there is square root x minus 1 upon x. So what we do? We write again this dy by dx. It means this time we write only square root x minus 1 upon square root x. Now this time we differentiate only this bracket term. And this term remaining as it is. So we write as it is again. Now differentiation of square root x. There is distributive property we use for differentiation. There is two terms inside the bracket, so both terms we differentiate. So first term differentiation, it means square root x differentiation is 2 square root x, 1 upon 2 square root x, or we can convert x power 1 by 2. So x power 1 by 2 can be written as 1 by 2 x power 1 by 2 minus 1, that gives us x power minus 1 by 2. So minus 1 by 2 become positive when we shift it into the denominator side, so it becomes 1 by 2 root x. Now this square root x in denominator can be written as minus 1 by 2 in numerator. Its differentiation will be minus 1 by 2 we write in front, and minus 1 power we write in the its power. Now 2 square root x minus 1 upon square root x, and here we see 1 by 2 square root x, and this minus 1 by 2 multiply with this minus, it becomes plus 1 by 2, and there is minus 1 by 2 minus 1, so it becomes minus 3 by 2, and we can write in denominator, so it becomes x under root x. X means 1 power and 1 by 2 means square root x. So this is the answer. We can take common 2 square root x common from the second bracket. So outside we write here in denominator 2 square root x after taking common. First bracket we write as it is. In second bracket after taking common, so first term become 1, and second term only 1 by x will left. So this is the answer. We can multiply if we want, and 2 we can cancel out, and finally we get 1 upon square root x bracket square root x minus 1 by square root x bracket 1 plus 1 by x. This is the answer. Similar problem next we are considering, again using chain rule problem. So here is question: differentiate x square plus 1 upon x square whole cube. First we assume it equal to y, then we differentiate it with respect to x, and according to chain rule this bracket termed as x. So x cube differentiation we find out according to our differentiation law. So 3x square is the differentiation, 3 then x power 3 minus 1, that means x square. So we write here 3 x square plus 1 upon x square whole power 2. But we see there is the bracket, and inside the bracket there is not x, there is x square plus 1 upon x square. So we use chain rule. So we write here x square plus 1 upon x square with differentiation sign. So this time we differentiate it again, and differentiation of x square plus 1 upon x square differentiation is 2x, and x power minus 2 when we shift this 1 upon x square in numerator, and its differentiation is minus 2 x power minus 2 minus 1. It means x power minus 3. So we get the final answer 3 x square plus 1 upon x square whole square, and 2 taken common. So taking 2 common, we write in the front side x minus x cube x power minus 3. So this is written as in denominator to make it power positive. This is the answer of this question. So 6 into x square plus 1 upon x square whole square x minus 1 upon x cube is the answer. Next we are taking another problem of differentiation. So this is another problem, and question is again same, differentiate with respect to x. So first we consider equal to y, and there is first is considered as u, second is considered v. So differentiation of u into v, it's a differentiation of, we use formula. So first we write u as it is. So x plus 1 upon x we write as it is. Then differentiation of second bracket x square minus 1 upon x square. Then plus, then second bracket we write as it is, x square minus 1 upon x square. And differentiation of first bracket d upon dx x plus 1 upon x. Now first bracket as it is we write down, and differentiation of x square is 2x, and 1 upon x square differentiation, first we send x square in numerator, it becomes x power minus 2, and x power minus 2 differentiation, so minus 2 we write in front, and then minus 2 minus 1 we write in the bracket, plus x square minus 1 upon x square write as it is, and differentiation of x is 1, and 1 upon x differentiation is, so x power minus 1, its differentiation is x power minus 2. Now make it power positive after, and taking common, 2 is common from second bracket, so we write 2, so x, and this is become positive, minus minus positive in multiply, x power minus 3, and plus x square minus 1 upon x square, and here 1 minus x square, x power minus 2, it becomes positive when we write in denominator x power 2, 1 upon x power 2. Now we write 2 in front, so x plus 1 upon x, and x plus x power minus 3 can be written as 1 upon x cube to make it power positive, plus x square minus 1 upon x square is written as a plus b a minus b, so x minus 1 upon x and x plus 1 upon x, and second bracket 1 minus 1 upon x square written as it is. Now again taking common, x plus 1 upon x is common, so x plus 1 upon x taking common, we get 2 as it is, x plus 1 upon x cube we write as it is, then plus x minus 1 upon x, then x 1 minus 1 upon x square, because this bracket is taking common outside, and then bracket close. We can inside multiply and then further solve if there is possible, otherwise this is the final answer. So this is only algebraic properties we use here. So after multiplying we get 2x, then 2 upon x cube, then x multiplies with 1 we get x, x multiplies with 1 upon x square we get 1 upon x, then minus 1 upon x multiply with 1 we get minus 1 upon x, then minus 1 upon x multiply with minus 1 upon x square, it becomes plus 1 upon x cube. So like terms are there, this 2 upon x cube and 1 upon x cube are like terms, so after we taking LCM x cube we get numerator 2 plus 1, it means 3 upon x cube, and similarly 2x plus x we get 3x, Then minus 1 upon x, minus 1 upon x, there is a like terms, so it gives us minus 2 upon x. This is our second bracket. First bracket is as it is, we write down x plus 1 upon x. So this is the final answer. I hope you have understood, enjoyed. Okay.